Welcome all my dear student of SYBSc class. In previous lecture we studied the partial differential. In this partial differential chapter we have studied the theorems of differentiation and some problems related to theorems of differentiation. Now in this RTA today we are going to see chain rule. Chain rule is very important when equation is expressed in a parametric form. Okay. Now in order to study this chain rule, first of all we have to see, or we have to look back towards the previous points in which so far we have discussed the differentiation of a function f of function f is equal to f of xy. Now, and this function with respect, this is a function with respect to variables x and y. Now we consider the case where x and y are themselves a function of another variables like x of u and y of u. We have to substitute, and if we wish to find df by du, then we have to substitute the function x of u and y of u in f of xy, and we have to find out the value of df by f, or df by du, that is differentiation of a given function with respect to another variable u. Okay. Now when we substitute and derive the final result, then it helps us to find quickly the desired result. But this is happen in simple case. When case is complicated or problem is complicated, then it is easier to use total differentiation rather than chain rule. Okay. Now we are going to see the derivation of chain rule. Let f be a function of x and y, that is f is equal to f of x comma y. Okay. We write f is equal to f of xy. If x is a function of u, we can write x is equal to x of u. If there is another function y is another function of, and this is nothing but y of u. Okay. When u is changes by u plus delta u, x is changes by x plus delta x, and y is changes by y plus delta y. Consequently, f is changes to f plus delta f. Now this can be written in a standard format, that is by usual method f plus delta f is equal to f of x plus delta x comma y plus delta y. Take this f on RHS side, we have delta f is equal to f of x plus delta x comma y plus delta y minus f. But what is f? F is a function of f of xy and can be written f is equal to f of xy. Therefore we can write delta f is equal to f of x plus delta x y plus delta y minus f of x and y. As like total differentiation, here we have to also make a little arrangement in order to obtain the chain rule. What we have to do? We have to subtract and add f of x comma y plus delta y in this term. So by subtracting and adding this term f of x comma y plus delta y, this equation becomes delta f is equal to f of x plus delta x comma y plus delta y minus f of x comma y plus delta y plus f of x comma y plus delta y and minus f of xy. When we subtract and add the same term, then this equation remains unchanged. Okay. Now, dividing both sides of this equation by delta u, we have delta f by delta u is equal to f of x plus delta x comma y plus delta y minus f of x comma y plus delta y divided by delta u. Similarly, f of x, this term f of x comma y plus delta y minus f of x comma y divided by delta u. Now again make some little arrangement like this, delta f by delta u is equal to f of x plus delta x comma y plus delta y minus f of x comma y plus delta y divided by delta x and multiplied by delta x and delta u as it is. That means here we multiplied by dx and divided by, we multiplied by delta x and divided by delta x. By multiplying and dividing by the same term, again this term remains unchanged. Similarly, here also f of x comma y plus, y plus delta y minus f of x comma y upon delta y multiplied by delta y, divided by delta y and multiplied by delta y and delta u remains as it is. Here also when we multiplied by delta y and divided by delta y, again this term remains unchanged. Now taking the limit as delta u tends to 0, then delta x tends to 0 and delta y tends to 0. When we substitute the limit in this equation, we have first term limit delta u tends to 0, delta f by delta u is equal to del by f by del by u, or you can write df by du. Same is there, instead of del by u can also write simple d. Okay. Similarly, put the limit for this term, that is limit delta x tends to 0, f of x plus delta x comma y plus delta y minus f of xy upon delta x. This term gives us del by f by del by x. Now when we substitute the limit for this term, where we get limit delta u tends to 0, delta x by delta u is equal to dx by du. Here u is a only function, or as u is depends on u only. As here x is depends on u only, and that's why here we substitute the limit. Now apply the limit to this term like this, limit delta y tends to 0, f of x comma y plus delta y minus f of xy upon delta y is equal to del by f by del by y. And again last this term, apply the limit delta, limit delta u tends to 0 dy by du. Here y is a function of u only, just like this. Here x is the function of x is the function of u only, and here y is function of u only. Okay. Now by considering this limit, let's mean this, and last this. When we substitute or when we consider these limit for this equation, or by applying this limit to this equation, we have here, instead of this term, we get df by du is equal to del by f by del by x into dx by du plus del by f by del by y, this one, into dy by du, and this is nothing but chain rule. This is called chain rule of partial differentiation. This expression provides a direct method for calculating the derivative of f with respect to u. Okay, and I am already told you that this chain rule is very useful in order to this chain rule is useful for a equation which involve parametric terms. Okay. Now instead of a single variable, if there are two variables, that means x is equal to x of u and v. In this case only there is only one variable. U is the variable and which depends, x is the variable is depend on u only, and y is the another variable depends on u only. But instead of single variable, if there are two variable u and v, and y is equal to y of u and v. There are two variables. Now for this, the chain rule may be written like this: df by du is equal to del by f by del by x plus into dx by du plus del by f by del by y into del by y by del by u. And for another variable, df by dv is another variable, we can write del by f by del by x into dx by dv plus del by f by del by y into dy by dv. Here we can write del by or d, both are same. Okay. This is, suppose this is equation 2 and this is equation 3, this is equation 1. As equation 1 represent the chain rule for single variable, then equation 2 and 3 represent the chain rule for two variable. And in general case, or we can follow the similar steps as given below, as given above, or as given in this explanation. In a general case, we can write the chain rule like this: f is a function of x, y, z. There are many variables. Then f is a function of, okay. Then x is a function of x of u, v, w. Similarly, y is another function of y, u, v, w. Then last z is function of z of u, v, w. And for this is the general format or general case. This is general case, and for this general case, the chain rule is df by du is equal to delta f by delta x into dx by du plus delta f by delta y into dy by du delta f by delta z into dz by du. Okay, this is the first chain rule for x with respect to s, differentiation of f with respect to u. Then chain rule of chain rule for function f with respect to another variable, that is v. By the similar method, delta f by delta x into dx by dv plus delta f by delta y into dy by dv plus delta f by delta z into dz by dv plus so on. And last, df by dw is equal to delta f by delta x into dx by dw plus delta f by delta y into dy by dw and delta f by delta z into dz by dw. In this way, we studied the chain rule for a single variable, chain rule for two variable, and this is the general case of multiple variable. Okay. Now using chain rule, we have to find out solutions for some typical problems. Consider the first problem. The first problem is if u is equal to x square plus y square and x is equal to 80 square and y is equal to 280, then find the differentiation of this u with respect to t by using chain rule. I am again going to repeat the problem. We are having the function u is equal to x square plus y square, where x is equal to 80 square and y is equal to twice 80. Now we have to find out the differentiation of this function u with respect to t. Okay. Now solution: given u is equal to x square plus y square, x is equal to 80 square and y is equal to twice 80, and we have to find du by dt. Okay. For this purpose, the chain rule is simply du by dt is equal to delta u by delta x into dx by dt plus delta u by delta y into dy by dt. I am again going to repeat that instead of this, because this is a partial derivative of the function u with respect to x, and this represents the partial differentiation of u, same u with respect to y. Okay. Now here substitute the value of u, x and y. After substituting the value, we get dA by dA by x in bracket value of u is x square plus y square into d by dt, value of x is 80 square, last dA by dA by y, value of y is twice 80 and dA by or d by dt, dA by dt, dA by t or dy by dt in bracket y is twice 80. Here by default I write this, but we have to write value of u, that is x square plus y square. Now simplify each term of derivative in this equation. We have value of this term, so or derivative of this term. What is the derivative? Derivative of y square with respect to x is 0 and derivative of x square is x square with respect to x is 2x into derivative of 80 square with respect to t is 280 plus derivative of this term by similar method we have 2y and last derivative of twice 80 with respect to is twice a. Therefore, we can write 2 into 2 4a x t, 2 into 2 4 x a t plus 2 into 2 4 a y. But value of x and value of y is 80 square and twice 80 respectively. Therefore, we have du by dt is equal to 4a t and value of x is 80 square, similarly 4a and value of y is twice 80 and finally we have du by dt is equal to 4a square t cube plus 4 into 2, that is 8 a square t. This is the differentiation of the given function by using chain rule. Now consider another problem. Problem number 2. Another problem. If f is equal to under root x square plus y square and x is equal to p cos theta and y is equal to q sin theta, obtain dA by f by dA by theta, that is partial differentiation of this given function with respect to theta by using chain rule. Solution: given f is equal to root x square plus y square, which is nothing but x square plus y square bracket raised to 1/2, then x is equal to p cos theta and y is equal to q sin theta. Now what is the chain rule for this solution? Simply chain rule is like this: df or dA by f by dA by theta, df by d theta or dA by f by dA by theta, both are same. dA by f by dA by x into dx by d theta plus dA by f by dA by y into dy by d theta. This is the chain rule for obtaining df by d theta. Suppose this is equation 1. Now substitute the value of f is this, x is equal to this, and y is equal to this. We have df by d theta is equal to delta by x in bracket x square plus y square bracket is to 1/2 into d by t theta p cos theta plus delta by y in bracket x square plus y square bracket is to 1/2 into d by d theta, and value of y is q sin theta. Okay. Now solve this differentiation. We have, what is the value of this? X square plus y square bracket is to 1/2 into 2x, okay, into this minus p sin theta plus y under root or x square plus y square bracket is to 1/2 into q cos theta. Or again simplify or write this equation once again. 2x minus 2x p sin theta, okay, 2x into 1/2, here 1/2, because 1/2 into x square plus y square bracket is to minus 1/2 into 2x, therefore this term minus 1, plus 1/2 into 2x, this 2 and 2 get cancelled here. Here only we have minus x p cos theta plus here also 2 is getting cancelled with 1/2. We have y q cos theta upon x square plus y square bracket is to 1/2. Now again substitute the value of x and y, that is p cos theta and q cos theta in this equation. By substituting the value of p, x and y, we have df by d theta is equal to minus x, value of x is p cos theta and p sin theta as it is, plus value of y is q sin theta into q cos theta as it is, divided by x. Here also again substitute, we have substitute p square cos square theta plus q square sin square theta bracket is to 1/2. Again simplify this term, minus p square sin theta cos theta plus q into q square sin theta cos theta divided by p square cos square theta plus q square sin square theta bracket is to 1/2. Again we can simplify this term and we have df by d theta is equal to q square minus p square sin theta cos theta upon p square cos square theta plus q square sin square theta bracket raised to 1/2, and this is the final answer of the given function by using chain rule. Now we are going to see one more problem. Problem number 3. In problem number 3, we have x is equal to, x of u is equal to 1 plus u and y of u is equal to b u cube and f is equal to f of xy is equal to x e raised to minus y. Now we have to find out the rate of change of this given function with respect to u, that is df by du. Want to find this? Df by du gives the rate of change of this given function with respect to u. For this purpose, again solution and given is like this, and we have to find out. Now write the chain rule. Df by du is equal to or very simply we can write, we have x, then delta f by delta x is equal to, where we have the function f and we differentiate this function with respect to x. Therefore delta by delta x e raised to x into e raised to minus y, and when we solve the differential equation, that is when we take the differentiation of x e raised to minus y with respect to x, then we e raised to minus y. Similarly, delta f by delta y, that is differentiate given function once again with respect to y. Here we differentiate the function with respect to x, and therefore delta by delta y into x e raised to minus y is equal to, here again x into minus 1 e raised to minus y, or which is nothing but minus x e raised to minus y. Okay. Now differentiate delta here delta x by delta u, that is differentiate this x with respect to u. We have delta by delta u in bracket 1 plus a u. Again here we are having answer only a, because here differentiation of 1 with respect to is 0 and differentiation of au with respect to u is only a, and lastly dy by du or du by du, then that is means we are going to differentiate with respect to u. We have delta by delta u of bu cube, and differentiate this term, that is 3bu u square. And now we are going to write the chain rule. Chain rule is df by du is equal to df by f by df by x into dx by du plus df by f by df by y into dy by du. Then substitute the value of each term. We have df by du is equal to value of this term df by f by is e raised to minus y into value of second term. This term is a plus value of this term is minus x e raised to minus y into value of this term, last term, that is this 3bu square. Now solve this by simple method, or after solving this we get a e raised to minus y minus x minus 3x b u square e raised to minus y. Again we can simplify this simply by substituting the value of y and x, that is this one and this one. After substituting the value of x, y, we have df by du or df by f by w a e raised to value of y is minus bu cube minus 3 in bracket 1 plus au b u square value of u square is again bu square and e raised to minus bu cube. In this way you can get the final answer.